Greetings, dear friends, fellow programmers, and those aspiring to be. Today, I would like to welcome you to my channel and to give you an exciting video that we are going to talk about today. We've spoken about many different topics related to closures, but all of them were positive thinking. So I would like to reverse that and today speak about potential pitfalls you can encounter while utilizing closures. Because with great power comes great responsibility, and closures in JavaScript are extremely powerful, so I want you to be very aware of potential issues you can encounter while utilizing them. So if that sounds like something you're interested in, please do sit back and enjoy the ride. Of course, if you are new to closures or just need a brain refresh on the topic, I would like to kindly invite you to take a look at my previous videos where we were discussing closures all the way from beginnings to the memoization, which is something like advanced closures topic. And now that your memory is all fresh and you have all the basic understanding about closures, let us discuss potential issues you can encounter with them. I would like to get this video started from the topic that is extremely important in my opinion, and it will be so essential to understand and be aware of, because if you do not consider it, you will get into trouble all the time while working with closures. Now, let us think about closures in general. What is their main benefit? If you mention the fact that they will remember the state of variables within the scope of a function that is a closure, even after the function has stopped executing, you were completely right. But these values that we are storing need to be stored somewhere, right? We need to put them in memory where they're going to live and be at our disposal whenever we ask for them. So that can cause issues when you're not careful about the amount of data you are storing in memory, because you can easily get too much data in memory and store it even though you do not need it, and that is going to cause memory leaks and basically completely freeze your application. This issue of memory leaks while working with closures can happen when you are keeping references towards huge objects or DOMs while working with browsers, because closures store their lexical scopes in memory as long as they are being referenced by something. This might sound a bit abstract, so I want you to jump with me to the IDE where I can show you in code how this looks like, and that way you will have a better idea about what you need to be careful about. So let's do just that. And now that we are back in our IDE environment, I would like to share with you an example that I wrote just for this purpose. So we have a very simple closure that we created, which is called createHeavy function. Inside of it, we have a variable called large object. And this variable will contain an array of 1 million items inside of it. And each item is going to be populated with a star character. So we will collect 1 million locations in memory and populate them with characters. So when we instantiate this closure, these 1 million items in memory are going to be allocated and kept alive as long as we have a reference towards this closure and the local variable inside of it. So if we do this multiple times, we will very quickly run out of memory. Even with today's very powerful and memory-heavy servers that we have at our disposals, we're still going to struggle to keep a lot of items like this one. Even more so when we are doing it without the actual need for doing it. To avoid this issue, I want you to be very careful and to nullify references to local variables inside of closures that are no longer needed. When you do that, when you nullify the reference towards this array, for example, garbage collection that is taking place inside of JavaScript engine is going to understand that the variable, which is large object in our case, is no longer referenced by anything, so it makes no sense to keep it in memory and just use up your resources. So it will free up that memory and deallocate those memory locations, freeing them up for the upcoming usage. To fix this issue, you can do one simple thing that is going to make all the difference. So when we know that garbage collection is going to free up the resources, when the references no longer exist towards this variable, what we need to do in order to ensure that these memory locations are going to be freed up only after we are done using them, we can do the following. We can, after we have instantiated this variable and populated it with seed data, we can now make our function be a variable, which is going to do what it did before, and after that is done, garbage collection can perform its magic and deallocate these memory locations, making them available for future use. After that, we just return the function result. Basically, what we are doing here is keeping exactly the same behavior with a small difference that memory is not going to be utilized improperly, but it is going to be freed up when we do not need it. Because in the previous scenario, large object would be in memory even though the function has stopped executing. And that is no longer the case, so we can press delete key and make this irrelevant as it is irrelevant. Now, I think is a great moment to start discussing our second pitfall when it comes to using closures. When you create a closure inside of a loop while using var as a keyword for declaring a variable, you will stumble upon a very serious issue. Let me show you what I mean. Let's jump to the IDE and I'll show you exactly what I mean. So right here we have a simple example. At least it looks simple enough. So as you can see right here, we have a variable that is an array where each function should log a different value for a variable I. But when we run this, we are going to receive a different result. As you can see, we're printing 3 every time. That is because we are using var keyword, which is function scope variable, not block scope variable. So what we are getting here is the result of the fact that all the closures are sharing the same reference to a variable I, which ends up being number 3 in the end. So we are not storing current value of the variable I to each closure, we are storing a reference to a variable I. So when we keep a reference to a variable in our closures, that reference points to the last value that was stored inside of it. So you are not storing the value of the variable in a closure, you are storing a reference towards the value that is in the variable. So when you update the value that is being stored in that referenced variable, you are not changing the reference itself. The reference that is going to be stored in our closures is going to be exactly the same memory location, but the value in that memory location is going to be the final value that we left in the end of executing our for loop. And this is not what we might expect here. And the solution to this problem is going to be very simple. We're just going to use let instead of var keyword for our I variable. When we do that, we will have a different instance of a variable for each closure because let will define our I variable as a blocked scope variable. And when we run this, we have 0, 1, 2. That is because we do not have the same reference in our closures anymore. If you still struggle understanding what is happening here, I kindly recommend you to take a look at the previous videos dedicated to scopes that I posted previously, because it will make things easier for you to understand how they work under the hood in JavaScript. And the third and final issue that I want to cover is going to be dedicated to maintaining state in our loops, because closures can make it tricky to maintain the consistent state within loops. I do not want you to think this is something abstract, so let's jump right to our IDE and I'll show you in action what exactly I mean. We have a very simple example with a for loop where we are iterating from 1 to 3 and we are creating a set timeout function inside of it and logging the value of I every 1000 milliseconds. And when I run this code, we'll get the following result: 4, 4, 4. So what is the reason of this happening? This is happening because set timeout is creating a closure and its own scope when you invoke it. So it will enclose the reference towards the variable I, and that way it will just keep the same value that is the last value we have inside of it. This is happening because set timeout function is creating a scope of its own and its own closure where the reference towards the value I is stored, and basically when we update the value to the value 4, it is just stored in the memory space. And when this happens, we are basically encountering a very similar issue from the previous example. We are again referencing the same memory location from within this closure. And the easiest way to fix this is by utilizing immediately invoked functions. This is a concept I will cover in future videos because it's very important and one of the main important features you need to know about JavaScript. So I will cover it in detail in the future, but for now I just want you to think about this as something we already covered in the past, because when we create a new function, we are creating a new scope for that function, because in JavaScript we have function scopes. If you do not know this, take a look at the video dedicated to scopes and you will know everything I'm speaking about right now. When we do this, we are creating another scope where we are sending a reference to the variable I as a parameter, and that way we are creating a new variable dedicated to that function scope and not sharing it across the rest of the set timeout function scope. That way, we are ensuring that we have created separate variables for each execution within this block of code. Let me show you what I mean. Right here, we have added a function that is going to receive I as a parameter, and inside of it we keep the same exact code we had before. So this part right here is exactly the same as this right here. And we are wrapping this code inside of a function, anonymous function we created here, which gets immediately invoked. So this part right here is indicating that this function that we have created should be immediately invoked. And when we do that, we are creating a new function scope that is going to store a separate value for I. And when we execute this, we get 1, 2, 3. These 4s are from this part right here, just to be clear. So when I comment this out and run this again, we get just 1, 2, 3. And that's exactly what we expected to receive. Isn't it fascinating how understanding these concepts that are not so complicated on their own can make you an amazing developer? Because by understanding these types of pitfalls, which are not very simple, I have to admit, because I've struggled quite a few times by not understanding some core concepts of JavaScript, so that is exactly why I decided to teach you and share with you my experiences and how to tackle those problems in the future. If you found this video useful and you think you will benefit from it in the future and not have such a difficult time figuring out these issues because you'll have them in back of your mind, I would like to invite you to subscribe to the channel, because that way you will never miss one of these very important and educational videos again. Right now, I would just like to thank you for watching and wish you an amazing day. Happy coding!